I'm just a noob researcher. So I'll be covering web caching fundamentals, and see, it will like I will go deep down into how caching mechanism works and how do you find those bugs in this PPT. So is my screen visible, right? Yeah. Let's start. So what do you mean by caching? So it's uh, it is a concept used by the origin servers, like the main servers, and that is used for like copying the actual requested data. So for an example, let's take a example of library. So um, let's say there is a library and there are many books, and some users might read very like popular kind of books which are very requested frequently. So what librarian does is instead of going to like copying that uh, all of the books, she keeps that those books on her table. So whenever a user wants that, it will be like fetched very easily. Or let's take a example of fast food counter. So the chef that makes the burgers, he keeps the pre-made burgers. So we'll keep that in heat lamp instead of every time he makes the new burger, so that the time will be saved. So just like that, cache mechanism is like okay. So cache mechanism is like some which is used by the origin server that saves the time, like send the request to the user. So what it does is so let's cover different kinds of cache. So browser cache. So browser cache is like right on the user's phone or computer. So especially in local disk or RAM, what it does, it's like when a user visits a website, their browser, like Chrome, Safari, and saves the heavy, unchanging stuff. So let's say images or fonts or colors. So every time user requests that, like it does not means that the origin server, the main server, will respond every kind of user. So what it does, like the browser that save these kind of repeated requests and the resources in its own cache, so that it saves time. And like using like this, the origin server don't get loaded with too much of requests. Then there comes CDN, the most common mechanism. So they are like scattered. These are the servers who are scattered all over the globe, which are also called points of presence or POPs. So these means like companies like Cloudflare or Fastly, they use this to store copies of full responses and API data physically closer to the user. So if someone in Tokyo requests a site hosted in New York, the CDN servers it from serves it from the Tokyo server. Keep things light and fast. So using that, um, the origin server saves much of a time and the minimizing the response overload. Then there comes the reverse proxy cache. So these are mostly used as Nginx or Varnish. So what they do is like standing directly in front of the main origin server. So softwares like Nginx or Varnish acts as a shield. So if 1,000 people ask for exact same heavy HTML pages or some kind of a huge code libraries, so the proxy server just hands out that saved copy instead of every time user wants to request to the origin server. So this protects the main server from getting overwhelmed and doing the same math 1,000 times. Okay. So next is application cache. So used by Redis and Memchain. So what it lives like where it lives is like deep inside the app's internal network. So these are frequently used as like they store fragments of data like active user sessions or specific database queries. It is very essential and as a quick reference as they are also known as the sticky notes for applications. So whenever a user wants a particular database query, like application cache feeds that saved uh, queries instead of every time it generates the new one. So these are four kinds of cache, and the most common one is the CDN cache, which we'll look into. So let's discuss about the HTTP request response side. So let's take an example of browser. Like user wants a resource, like anything, like HTML page, JavaScript, or anything that loads with a request. So it it usually 200 milliseconds for the request getting to the origin server and then respond directly to the user. So this is too much of workload for that origin server. So instead of that, it uses multiple mechanisms, which are our cache mechanism, and it works in two ways: cache hit flow and cache miss flow. So these are the two flows which are used and which determines what cache is stored and for how long it will be get stored, and depending upon how much frequently that request is made. So we'll look into cache hit flow. So let's say a browser checks like user wants something. So the browser will check its internal cache. So it will say, oh, I don't have this. This is a miss. Like miss means that cache is not holding any data or the requested data. So um, what browser will check is local disk and then see, okay, this requested resource is not available in my cache. So it will request the nearest CDN, which is like the Cloudflare or anything server. So DNS routes to that closest CDN, and then CDN sees, okay, now that the requested resource is available in my cache. So what it does, it matches the cache key. I will explain the cache key later, but just understand it as a identifier for any cache. So it will check cache key. And it is, okay, this requested resource is available in my cache. So it returns instantly and it saves the origin service time. It never sees the request. Now that's the cache hit flow where the cache is present in the cache mechanism. What does cache miss flow? Means the requested resource is not present in the cache. So let's take an example. Browser request resource and then it reaches the CDN. Now CDN says the memory. Okay, is not present. That means miss. And now it will go forward to the origin shield, which is like I have mentioned in here a reverse proxy cache, which are also known as origin shield. So it sits right before the origin server. So it will also check its cache and see, okay, that requested resource is not in my cache as well. So it forwards that request to the origin. The origin computes the response and sends the header back. So it will go to Shield and CDN simultaneously, which they both will save that cache, and because of that, the browser, like any other user who requests the same resource, will get it instantly, and origin server saves the time. So these are two flows, and one key insight is that if a single cache miss penalty populates the cache for thousands of subsequent users. What does that mean? It's like just a second. Okay, so what does that mean? Is like one user has to wait 200 milliseconds so that the CDN can save a copy. So like it will go with this whole flow. So like one user who requests resource will have to wait 200 milliseconds for that first cached response. And then, because of that, one person waits, the next 10,000 or other peoples who ask for the exact same page gets gets it at 10 milliseconds cache hit. So it saves the time. See, so this is the request response cycle. So any doubts? Okay. So we'll deep down into the headers. Like these are the headers which are responsible for the cache mechanisms which are included in it. So this is the max age, which determines how long that cache will stay in the cache server. So it determines that. Then it's S max age. So whenever something overrides the shared caches, it will determine like for how long it will take for that to override. Then no cache means must validate with server e tag. I will cover e tag later. So it usually affects the browser and cache. It means like let's say there is a requested source by the user, and then it will go to the CDN server. Then what uh, the origin server will check is like okay, there's an e tag in it. So whenever this e tag is there, it means origin server don't have like the response each and every time a user wants it. So no cache means like that is the header for the origin server to know that okay, I don't want to respond to this request frequently. Then there's no store means none of it will be stored in any cache. But this is like for some private info. If it like uh, they have to validate if it's like a private info, so they will put no store. And private, this is only for the browser. So like anything like the um, that I will say. Okay, am confused with this. Private means it will store in the browser only. It will not go to the CD. No store means never store in memory. Like just never storing that. Public means it's public. Like for example, HTML pages, JavaScript, CSS files. Those are public storage. So must revalidate. That will I will cover in like later topics. So this is the example. Like say for the static asset, like CSS files, JavaScript files, images. So see this means cache control is public, and it will max page is in seconds, and it means like it will store for 1 year. Immutable means like instead of this number, you can also put immutable. That means it will never expire. Also, dynamic APIs. So let's say uh, there's one response used by API. Due to that, like let's say some user request through an API, so that should not be stored each and every time like other user requested it. Then e-tags. Okay, e-tags unique identifier. We have seen most of the files hash like 25 or SHA minus 20, 1 minute. So the e-tags are like a identifier for that cached response. So let's say if a file have a MD5 hash, just like that, tag also works for cache. So let's say your file like it images.png, let's say that, and it has a MD5 hash. So the server what it does, like it puts an e tag on that file. So whenever it is like requested, it will check this e tag. So if it matches, then it will give this 300 not modified. Means will give an empty body because it is already present in the CDN server. So if it doesn't matches, then it will generate the response and give it back to the user. So if a single code or a single file name is like modified, this E tag will change instantly. So this saves bandwidth and it also notify the server when is this file last modified. Okay, let's move on. And then there is cache key. So these are a unique identifier for any cache that is stored in the cache server. So it includes protocols like HTTPS, HTTP, host, which is a host, and then URL path, query, or a selected address, which also includes encoding. And so the cache key means these are the uh, these determine what cache is being stored and uh, like for how long. So these are like one so normalized edge cases for this cache. So these are the the rules by the CDN servers like Cloudflare, which determines how the cache key is being handled. So the query ordering is like this: A is equals to one and A is equals to two, which is it will be completely different from B is equals to two and A is equals to one. Means these two cache keys will be different from each other. Then it is also case sensitive. If you change any letters, like will be in uppercase or lowercase, it will also affect on it. So this is very helpful in understanding how CDN works. So also it ignores the fragments. So whenever you put the hashtag section in the client side, it will ignore by CDN. Okay, now the query header. So query header are some kind of a mechanism to tell the CDN which cache key is like same or which it is different or not. Okay, let's take an example of that. Let's say when there's a counter for coffee and a user customer comes and request for a like vanilla latte, let's say, and then whenever uh, that request is being fulfilled, like uh, the coffee maker will give vanilla latte. So it will store that in its memory. Whenever the second customer will come and he also requested vanilla latte, the coffee maker will give the same recipe to him. But what if he wants more ice or what if he wants more like flavor in it? So this is like completely different. And this is why the vary header is there. So it differentiate between a personalized request cache key and a original cache. So vary header, for example, let's take this as accept encode, which it will be like differentiating two complete keys. Like let's say one key is the same and other key is also same, but the encoding is different. So the cache server will treat them as a completely different cache keys. And then let's say origin. So some course responses are there. Like let's say it comes from www.evil.com and then some other .com. So it will completely differentiate these keys. Keys are also treated as same. There's one thing that you have to look into is very star. So you have to ignore this at every cost. So it tells the CDN that every single request entirely unique. So in this attack, every request you make will be getting like not stored in the CDN because it is completely ignoring every single cache. So you have to ignore if you see this very star, you have in the response you have to ignore this because every single request you make will not be cached. Then this TTL and caching validation. So TTL, it means time to live. You have seen that header for this this max age. This is the TTL. So time to live for the cache to be stored in the cache server. So what's the timeline? So Once age exceeds the max age, this cache will be get stale. It is not no longer required for any user or the cache itself. So let's say developer he makes changes in his code. So he will put the new file to the server. So the old file will be get useless. So no one wants it, and it won't be like served to the new users or the users. So this file is now stale file. So it is not no longer needed in CD. And you have to ignore this stale caches because it is not necessary. Will it is they are like a rabbit holes for us. Now file vanishing. So there are different kind of um, mechanisms which are used by the developers to change this cache. So like there if there are any stale caches, the developer will update those stale to the newer version. So there are different ways for it. One is file vanishing, which means they will completely update the code and give a version. So this will be like updating that cache. So the old cache will be at stale. Then there's content hashing. So what they do is like whenever they make changes to existing JavaScript code or anything, they will put a hash file name. Uh, so it will be like updated in the newer cache things. Then the query parameters, they can also add one cache piece to it. So this v is equals to 2024 means that 2023 will be get stale and the 2024 will be get updated instead of it. So for purging, like this is very useful if you want the existing cache to get stale, like for on purpose, like for forcefully purging, but it requires admin access. The admin access. So Cloudflare and Fastly use this to kind of curl request for that. So any doubts till now? Okay, we'll go for it. So let's discuss the CDN architecture. So as discussed, I will go into the topics. Okay, so the global user base, which is like the browser or any local cache that is on the user system, which are known as global user base, and the edge pops, which are the CDNs, the original cache servers. They're also known as points of presence, which are physical data centers housing near to like every user so that the data can be provided fastly. Then there's origin shield. This origin shield is like, as discussed, it is right before the origin server. So it stored this database queries or any small codes, like fragments of code, so it saves time for the origin server fast processing. And there's also uh, any custom. So this is like a protocol where multiple servers share the same IP address, so that naturally routes users to the mechanically processing. So this will help any user who are there like requesting on the same IP address. Till now, Cloudflare have 300 plus POPs. Athemia has 400 plus locations. So this reduces the latency by up to 60%. Now, one thing is like have to look at, like understand this cache mechanism. You have to understand what cache gets cached. So there are two kinds of cache which are public and shared, and other one is private. So for the public one, it includes static assets like JS, CSS, PNG, and the public API responses, marketing or landing pages, which are frequently requested by every user. Then there's private, which are post delete requests, authentication related dashboards, and sensitive PI. CRS, CRF token session IDs. And all. So how the cache mechanism understand this is like, let's take this example. So the user make a GET request. So browser will see if it is a GET request, then it will go forward. So if it's not, like it will defaultly not cache it. So because like the sensitive data does not get cached, so it will move forward if it's GET request. So it it will ask itself, does this changes per user? If no, it will go forward. If yes, it will not store it. Then there's if it no, it will see if it's static like JS files, CSS files, or PNG. Then it will cache it for whichever the time the origin server decides. Or if not, then it will not store it. So this is the fundamental skill now. Do you guys have any doubts? Yeah. Are you asking for the attacking purpose or like, yeah, I will cover that in the tooling part. For the bugs, we have that option. So we'll cover that. So are there doubts in the fundamentals? User profile. So that is not possible because identically don't like cache and authentication related things. Yeah, I'm looking. Okay, the thing is, like, if you want to look how many it will take, like you will be going to use one identifier, your own identifier to know like how many requests you have made and how many requests have been cached by like cache server. So I'll cover that in the attacking part. Should we move forward with that? Okay, let's cover this. So let's start finding web cache points. So I will directly point to the steps and discuss how to find this kind of bugs. So as you have learned, how to what is cache and how the cache mechanism works. So it will be helpful for us to identify this kind of mechanism, what kind of mechanism server is using, and how to handle this caches and uh, find bugs to pollute this. So the first part is like detect the caching mechanism. So as discussed, many companies have various kind of mechanisms. So our first part is like determining which cache mechanism that server is using. So there are various distinctions between each and every cache infrastructure. So for Cloudflare, it will mostly see the CF in the headers, the response headers. So the CF means the CF cache status. So it will be hit, miss, or expired that you can distinguish easily. Um, then this pass the varnish. So mostly they're common, but like you will see these similar kind of headers in like other mechanism also, but it also depends upon what kind of response, like what kind of value they are providing. As you can see, X cache and the fastly, there is X cache hit or hit. So it's a semantic mistake, but it's hit or miss. And in this CDN 77, that's the same header, but we see the value is different. So you can determine what kind of cache infrastructure is using the response files. So this is it. The first step is detecting cache infrastructure. Step two is confirm the response is actually cached. So this is the main part, the starting part. This will be like useful for us and knowing like if this server is vulnerable to cache for or not. So what we will do, like first method will be uh, you always have to send the two requests, and based upon that you will know if it's like if your if it is in cached or not. The first request, if like method one, in the method one, check the age header text. So what we'll see, like if the request one, you make the normal request and the response had age one. So you will see, okay, this is like a fresh from the old. Then you will make request two and same viewer. So 5 seconds later, you will see the age as five. Now you know cache is being increased and your response is getting cached. Method two is like cache status header. So as you have seen the ages, so it might be status will be miss. Miss means there is no cache in that server for this request. And then it makes cache to request to, so it will get it use the or your request is being cached in the server. So these are the methods you will read and we'll see if the or request is being uh, captured in the cache. So one thing I was wanting to cover is like guys asked about how many hits it will take and start like how do we know that how many hits it takes. So um that is like very good question and that is covered by cache buster. So these are the like random parameters that we use for our understanding to see like like uh, what our responses are being cached or from like in the server or so like this distinguish from other users cache response so that we don't get the same response from that other user. So you can use any random identifiers for yourself and whenever your response is being cached, you will see it's identified. So then you know that this is my request and it worked. Okay. So your best targets will would be like homepage, the JS bundles like static JS files, then CSS files, login on all pages because these are very commonly used by everyone. So if you need it, the reach for many users as possible. So we mostly target this public endpoints. Now, this, now these are the two steps to check your response is being cached or what mechanism is like that server is. Now, the tooling part. This is the most exciting part as it covers the manual and automatic response. So, you know, this paramount, this is like the primary question for every account runner as the pub should have this extension. So, like you can see, these are the steps to how to install everybody knows. Then, you need is like, you need to be careful as it also contains some various first priorities. You need to test manually each and every time it gives you the results. So and these are the steps like you can see how to run just like right click on the extension of any endpoint that you want to test and it will get the headers to its word list and then whenever it outputs you have to um, check manually if it like giving the expected results or not and you have to check the three things. Like first, you have to confirm if your uh, like identifies like the parameters or the headers are being reflected in the responses. If they are getting reflected in the responses and are also getting assured, this means this is a possibility for the bug because These are the like entry points for explore. So if it you have to check two things like your reflected responses are being cached in the response and also like how they are being cached, like in the locations of where they are being cached. So these are the things that you have to make. So don't only rely on this. Uh, it is also it is only for like testing purposes. Then I have two tools. It is manual testing and there's tooling part. So we'll cover the manual. The first thing is like you have to map out the endpoints. So we browse to the tab, like usually click anything and then go to the bar and see the hit responses. Like whenever you see the hit, you can determine if it's like being cached or not. You can also see bug logs to fetch. This is the most, this is the most unique thing that you can directly check the X cache headers using the pop logs. Then the second part is like first unfeed response, unfeed habits. So what this usually means is like, for each cached endpoint, your parent miner will still list of like the common proxy headers, and then you have to check like you have to check if any headers are being reflected or not. So you have to purge it for the unfeed. So these are the like random steps. The third part is like identifying the reflectors. So like check the response headers and JavaScript and target redirect targets for the injected values. So you can see it is getting reflected in the script source or any location or window location. So like if it's is like providing a high input command. So this is also a Perl command for them. Then post step is confirm the cache storage. So you also have to check like for yeah, you also have to confirm like after injecting, you have to wait every 2 seconds because the URL that you are requesting should be get injected and you should see the response immediately. So each and every time you make this second request, you have to wait for 2 seconds and you have to start with a fresh browser to see if your response is being cached or not. Then, when whichever the location is being cached, you can make an expert for that. So we cover that later. Then, then comes the workflow tooling part. So this is the like phrase asking about the content. So you see, whenever you make requests, the work determines the content length and it updates automatically. So this is not like it will ruin our testing. So what we do is like we disable the update content length, and this is also useful for HTTP request smuggling attacks. And you can also enable the follow redirects to see if the location header reflects your cache response or not. Then add a cache debug. So you can like use this for your own understanding of like how many times it is being cached or how many times it is giving you the same response or not. Now, yeah, one thing is that you can even set a long timer. So cached response whenever it is being cached, like you have seen, it's 200 milliseconds it to be cached. So your browser work might hit that long request timelines. So what you have to do, like you have to wait for that long. So you can set this option in the repeater, then match and replace. So this is very helpful. Um, whenever you can like inject in headers, you can use this for injecting those cache key identifiers. So this will be helpful for distinguishing the cached or uncached responses. So for birth vectors, these are the essential. This is param minor, HTTP request from logger Christmas. turbo into the authorize and cheat needs. You can use this for more advanced purposes and you can play with and understand it, whichever suits you. And these are also some curl that you can use, share this out, and this is very useful to use more advanced results. Then this is the most important part as it covers where your responses are going to store. So determine from this you can make your exploits accordingly. So let's take some examples. So let's say your requested uh, parameter or something like your uh, poisoning attack are being stored in the HTML scripts. So if it's sorry, the JavaScript script tag. So whenever it is stored in it, so you can use this for manipulating the of the user in using your own JavaScript files. And this is very critical. Second is location handling. So the redirect handling. This is very useful as this will be the combination of cache avoidance and open redirect. So you can target those users to be redirect to your own page. This is the most commonly used and it gets you high impact. The HTML meta text, if that response is being cached in the HRF, you can also target that users in your personal page. Then inline JS variables. So you can also see if those responses are being stored in the variables, JavaScript variables. So you can manipulate with those variables for your own exploit. And then HTTP response rule. So you can also see the reflected headers in the variable page content, and this is very um, not that much of an impact, but you can see if whenever you can use any injection or what, like you can also use CSS injection if it has successfully stored. Then there's set key header. So this is what use that I can use this like uses this type of headers to scope that user into the attacker's domain. So this is very useful. So, yeah. So these are very advanced attack vectors. So we covered this, and they are not most commonly used. You can use them to get advanced. The first one is vector. The threat is usually like a get request and doesn't have a body. But what if we attach one anyway, like the CDN only at the URL parameters, but the some web frameworks are configured to prioritize body parameters over URL parameters. Server processes our poison body payload, but this CDN caches the result under the completely innocent this URL. So this is like a Trojan horse, like it completely with a cache mechanism will completely ignore this body parameter as get requests are not usually sent using this. So we will completely ignore that. But what if the origin server prioritize this, stores your this payload and it will poison accordingly on the parameter then vector B. So that's HTTP method overload. You can use this to overload any HTTP methods. Some APIs that you use this to protect a GET request. It can usually be a GET request. The CDN, which ignores the header, thinks it's fetching a normal web page. But the server, however, processes the delete, it resulting into delete successful. So that you can use to override the methods instead of just relying on the cache keys. Then vector C is request splitting. So the server doesn't properly sanitize line breaks in our headers. We can literally insert second. hidden HTTP request into the middle of our first one. So what we can do, the server processes both, but the CDN gets confused and caches the response of the secret admin under under the URL of the normal request. So this is like a normalization then vector D, which is cache poisoning by DDoS. You can literally make any uh, static web page or static JavaScript files or frequently used files and make them unavailable and store that into the cache so that every user who requests those pages will be get um, 400 or 500 errors. So you can literally cache these kind of errors to make that website a profit. But you have to frequently cache that time to time. So this is also most important part as you can bypass some defenses which are being implemented by the developers. Let's take some examples. So what if first one is what if X forward post is blocked? So you can use some other variants such as X post, X forward server. Instead of that, you can test and see if it's getting reflected or your queries being. Then the second one is array header. So see, Gary header is like dangerous for us because it completely differentiates our cache key with the other cache key. So like even if you get anything being cached, your the second uh, cache key will be get ignored as it will treat it completely different. So so what we can use is like some kind of headers like X origin or get get one, then post. Okay, you can use some other variants to prioritize it. Then sometimes our base blocks the injection characters, so we can use the different kind of encoding in those headers to achieve our target. So this is the basic one as you can yeah. So this is a very basic one. You can see how we differentiate everything. So X cache miss, which means you have no cache copy. The first request or the cached expire, which means that X cache it means you are getting a cached response. Then 80 means the cache is a very fresh one and means it also means that caching may be disabled or TTN that is time to deliver also zero. Each chain rule, for example, say you get this or any you can see how many minutes this was getting cached. So if it's still fresh, you can wait for the next batch to get another response being cached. Then cache no stores means the server tells us that the cache it is not being stored and like you should completely skip this one. And as discussed very stuff, this is dangerous for us and it completely treats every request as like a distinct a response, like a distinct cache key. So whenever you see this, you have to be uh, because it is like making us very difficult for this poisoning attacks. And CF cache status expired. It is like a hard to copy, but it is expired. It's the past period. So yeah. Then this bypass one means they bypass the cache. So this is like used for the CDNs only to like distinguish the cache when expired or bypass. Then everybody knows the reporting format. So just for education understanding. So this is it, guys. Thank you for watching. I tried my best to understand explaining everything, but this is it. Okay, thanks.